Yeah, good morning. So we're all set, right? Shall we start? Okay. So in the last class, we were going through object class and especially object class methods. Like we saw equals method. So equals method, basically it is used to compare the contents of the objects. But by default, equals method functionality in the object class is same as double equal to operator, relational operator, double equal to, right? So we need to explicitly override it. Yes. And as we have discussed, so the reason why the equals method is defined in the object class is to make sure that, you know, all the classes inherit this equals method and they override this equals method to compare the contents of the objects. And through this equals method now, you see, the way the objects are compared in Java is standardized. Okay. So today we'll go through another method. So that method is hash code method. Okay, hash code. Just a second. Let me load this ID. Okay, so we'll go through this hash code method. The hash code method return type is integer type. So what does this hash code method does? Let's see. Basically, if you call hash code method on the object or using the object reference, it returns the hash code value of that object. For every object, you'll have a hash code value. So that hash code value will be written here. Yes. You see, you got this hash code value. So which is basically an integer value, you can say. Yes. So anyone got any idea about this hash code value? You see how exactly we use this hash code value. Okay. You're not even sure what is hash code. Okay, no problem. So at least now you got some idea. Also, it is basically an integer value. That's it. hash code value as in is an integer value. And you will find that here the hash code value, uh, you know, it is basically a randomly generated value using hashing algorithm, I can say. The hash code value is generated using hashing algorithm. You know, the input for that hashing function, okay, hash function or hash algorithm, I can say, is nothing but the memory address of the object. Okay, the input for hash function is actually the memory address of that object. It takes that memory address and generates a hash code value. You got a hash algorithm which is implemented by that hash code method, which takes memory address as input and returns a hash code value, which is basically nothing but an integer value. Okay, yes. So you'll find that for objects, every object will have a hash code value. Okay, let me run this code. You see, now for two different objects, you got two different hash code values. But the hash code values, always, is it guaranteed that always they will be different? Is there any such guarantee that hash code values are going to be different for each object, and why it is used? If anyone is familiar with it, just let me know. You can just check once what the answers which you know correct or not. Yes. Okay, so why do we use hash code values? Every object has a different hash code value, but is it always guaranteed to be different, or can it be same? I can say yes. The hash code values need not be different always, they can be same as well. The hash code value, it can be even same. Yes, there is a possibility that hash code values can be same. And why is hash code value used basically? Please do not use hash code values to compare the contents of the objects. The first thing is, do not use hash code values to compare the contents of the objects. Generally, hash code values are used when when we need to store these objects as elements into hash table data structure. Generally, this is one of the applications when we are supposed to store these objects into hash table data structure. So soon in the collections concept, we're going to learn that. Okay, we'll see that. You'll learn how to store objects into a collection. So one of the collection classes, it implements hash table data structure. So there we use this hash code value. Okay, yes. So as of now, what I want you people to understand is for every object there will be a hash code value. It can be different or it can be same as well. Okay, yeah, just a second. Yeah, sorry. So one instance where the hash code value can be same, I'll show you people. It is in case of string class. So you know, you will find that the hash code value for these two objects will be same. The hash code value for these two objects will be same. You see, why so? Here, can I say that S1 and S2 are referring to the same object or different object? Are they referring to the same object, S1 and S2, or are they referring to two different objects? They're different, right? Now, how can we confirm whether S1 and S2 are referring to the same object or different object? How do we know whether S1 and S2 reference variables are referring to the same object or a different object? So what to do? So we can use double equal to operator, as I told you people. You can use the relational operator double equal to. Okay. You see, if I run this code, it returns false. This comparison returns false. That means S1 and S2 are not referring to the same object, so they are referring to two different objects here. But you see, the hash code value is same. How come the hash code value is same here? That means are these two objects referring to the same memory location? You can say no. You know what? Again, you'll find that the hash code method of the object class is overridden by the string class. String class, what it is doing? It is overriding the hash code method of the object class. So you know that the string class inherits hash code method from the object class, right? It overrides it such a way that it generates the hash code value by taking that content or the data as input. Yes, it generates the hash code value by taking the data or the content as input, I can say. You see, if the content or if the data in the string objects is same, sorry, if the content or data in the string objects is same, then the hash code value also will be same. The hash code value is also going to be the same here. Yes. If the data is different, the hash code value of the string objects will be different. Yes. Okay. So once I would like to check with you people. So how is hash code value generated by that hash code method of the object class? Hash code method of object class, how it generates the hash code value? What it takes as input, the hash code method of object class, what it takes as input. Yes, it takes memory address of an object as input, and based on that, it generates hash code value. It takes memory address of an object as input. Yes. Whereas the hash code method in the string class, it generates a hash code value by taking the data which is stored in that string object as input. Yes, that is the difference. Okay, so soon I'll show you people one of the applications of hash code. Okay, so in the collections we'll discuss about it. Okay, yes, but do not use hash code to compare the objects. Okay, yes. Next, we got toString method here. Can you see this? So what is the return type of toString method? What is the return type of toString method? It's a string value, right? You see, it returns a string value. So now again, we'll do one thing. We'll call toString method on the product object. ToString method on the product object. So you see, the toString method of the object class, what it does is it returns a string. In that string, you'll have the class name at the rate followed by the hash code value of that object. Originally, the toString method of the object class, what it does is it returns the class name at the rate followed by hash code value of that object. That is what it returns. That is what it returns. Okay. So now I'll run this code once and I'll show you people. You see, I'm calling toString method here using the object class reference. Sorry, using the product object reference. So this is what you'll get. Okay. So this is the functionality of the toString method, which is defined in the object class. Now, what is the advantage of this value, which is written by the toString method? What do people think? So, is there any advantage for this? Yeah, of course, if it is not final method, then you can modify it. And toString method is not a final method. So, of course, you can modify it. Yeah. So as of now, you see, I can say that seriously, there is no advantage of that class name at the rate hash code value, that content written by the toString method. But I have to tell you people few more things. Just before I answer this question, what is the advantage? How we use toString method? I would like to show you people one more thing here. You know, did you people try printing the reference variable value? Have you people tried this? What happens if we try to print the reference variable value? You know, I'll show you people now. I'll run this code. So what is the output here? So if I try to print the reference variable value, so I'm getting a similar result. It returns the class name at the rate hash code value here. That means what we can analyze here. Yes, what we can analyze.
It is overriding.
Uh, it's not overriding, but you know, whenever you're trying to print that reference variable value here, internally it calls toString method. You got the point here. So what I'm trying to explain is, we saw that when the toString method was called, it returns that class name at the rate hash code value. But when I'm trying to print the reference variable value also, we got the same result, the class name at the rate hash code value. So what it indicates, so now this indicates that here the toString method, it returns, sorry, when we try to print the reference variable value, so basically internally it is calling the toString method. Whatever the value the toString method returns, that is printed here. That is what I can say. Okay, that you need to understand. But how is this useful for us? Actually, that content, that string which is written by the toString method, how is it useful? So I'll show you people. For that, I'll take string class as example. See, so I'll try to print, I'll try to call toString method here, and also I'll try to print that reference variable value. Okay. So let's see what happens this time. You see, so in both the cases, it prints that data which is stored in that string object. It prints the data which is stored in that object. Okay. So how come, you see, the toString method is returning that object's content in case of string class? Now you know the answer for that. In case of string class, so why it is returning toString method of the string class returns that object's content instead of class name at the rate hash code value? Yes, what's the reason? Because
The string method
yes,
represents the string value and hash value.
uh, the reason is I can say that it is very simple. The toString method of the object class is overridden in the string class such a way that it returns the content stored in that object. That's it. Okay, so hope everyone got this point. So the answer is simple again here. This string class is overriding the toString method such a way that it returns the content stored in that object, string object, which is printed here. Yes. So is it clear for you people? So that object's content is printed here. Yep, it is overriding. Uh, you know, this implementation of printing the or returning the object's content, okay, returning the object's data, object state here is more appropriate than printing the class name at the rate hash code value, right? Because we don't use, sorry, because we don't use the hash code or class name much. So instead, if it prints that data which is stored in that object, it would be more appropriate. Yes, that is what the toString method of the string class does. Okay, fine. So let's do one thing. We'll try to also override the toString method of the object class here. Sorry, product class. Now this toString method, I can say that it returns the string representation of that. It returns the string representation of that product object. Okay, that means the data which you got in the product object, we'll add it to a string and we'll return it. Yes. Okay. So what I'm doing, I'm creating a string here. You see the double quotes, this represents a string. And in between, we are adding the data which we are reading it from the variables. Okay. So the whole content of the product object. So we are returning it as a single string here. So string representation of the product object, I can say. String representation of product object. Yes. Fine. So now we'll see. This time I'll try to print that reference variable value of that product object. So internally what happens? Which method will be called? Internally which method is invoked here? Yes. Yeah. No, no. The toString method. ToString method will be invoked. Okay. Yes. As I told you people, toString method will be invoked internally. Okay. Earlier we saw that when I was trying to print the reference variable value, or even when I call the toString method, you got the same output. Why so? Because internally, when you try to print the reference variable value, it calls toString method internally. So internally, toString method is invoked. Okay, fine. So now I'll call that. Sorry, I'm trying to print the reference variable value. So now what happens? The toString method will be called. The products class toString method, you see, which we are overriding here, will be invoked, which returns a string which has got that product object's content. Yes. So let's run this code. See, just a second, please. Backslash and we'll move the cursor to the next line. Yes, you see. So, is it clear for you people? Hope you people got it. Please let me know if you got any issues.
Mahesh, I have one question here.
Yeah, yes. Tell me.
You see here, ID type is of integer. We are not casting it to the string, but it is taking it as a string. How is it? And even price is of the
Yeah,
float
you
type.
see, that is where we, actually we are trying to concatenate that integer value with string. That means adding the integer value to string, it makes it string. Okay, the whole thing becomes a string. So any value, if you try to add it to string, it becomes a string. Okay, the whole thing now is it becomes a single string where you got the ID, you got the name is already string itself, price, float, it is float type. Even that will be included to that string. So any other questions? Okay, good. So this is about toString method. Now before we move on any further, actually I would like to talk about few rules. We say equivalence rules, especially which you need to follow while overriding equals method. There are certain equivalence rules which we need to follow while overriding equals method. So I'll make you people familiar with it. You know, equals method is most important method because you see always we need to compare the contents of the objects. Okay, so where you will find the details. So in the specifications, in the documentations, you'll see that equivalence rules. Let's go through them. Okay, Java docs. You see, so this is the official site where you can find this Java documentation. Okay, now I pasted that link in the GoToMeeting chat. You see, these are all the list of packages. It says Java Platform Standard Edition. Standard Edition means core Java. Okay, so you got java.lang package here, right? In the java.lang package, one of the classes is object class. This is object class. and the method is equals. So no, sorry, just a second. So let's check this equivalence rules which you need to follow while overriding equals method. So the first rule, let's see what it says actually the description here. Equals method implements an equivalence relation on non-null object references. So this term non-null object reference, what does that mean? I'll tell you first. Now you see product reference variable which you got here, I can say it is non-null object reference. It is not a null, non-null object reference. Non-null means the reference variable which is not holding null reference. The reference which is not null. Yes. So for example, let's say I'll declare a variable product will assign null value. Yes. Now I can say that this product variable which you got here, this is null reference. It holds null reference, whereas product 1 and product 2, they are non-null references. They are non-null, means other than null reference. They hold some object reference here. They got some object reference. Okay, whereas product is a null reference. So you got it, all of you? Just this is the terminology which will be used generally to refer to that reference variables. Yes. You see what it says, the first statement here. So one of the equivalence relation, equivalence relations is reflexive. So for any non-null reference, this is a line which I'm reading now. For any non-null reference, value x, non-null reference value x dot equals of x should return true. X dot equals of x should return true here. Yes. That means if you got a reference variable, a non-null reference variable x, if you got non-null reference variable x, then comparing it with itself, comparing it with itself should return true. So that means product 1 dot equals of product 1 self reference, comparing with itself, so should return true here. Let's see whether our equals method does that or not. So we are overriding that method, right? You see it returns true. In the product class we have overridden that equals method. Okay, So, okay, this rule is satisfied. One of the equivalence relation rule, reflexive. The equals method is reflexive, I can say. Next, symmetric. So this is another equivalence rule which has to be satisfied by the equals method, which we override. So for any non-null reference values x and y, so you got two non-null references, two reference variables, non-null reference variables, x and y. So x dot equals of y should return true if and only if y dot equals of x returns true. Okay, x dot equals of y should return true if and only if y dot equals of x returns true. Yes. Okay. So that means product 1 and product 2 are non-null references now. Product 1 dot equals of product 2, if it returns true, then product 2 dot equals of product 1 should also return true. Product 2 dot equals of product 1 should also return true. Yes. Okay, let's see. So both the statements should return the same result. Always they should return the same result here. Next, hope you people got it. Next, transitive. There's another equivalence relation which needs to be satisfied by the equals method. So for any non-null reference values x, y, and z, if x dot equals of y returns true, y dot equals of z returns true, then x dot equals z should also return true. Yes. So I'll explain it here. So you got three objects. See, product 1, product 2, product 3. They're basically holding that object references. If product 1 dot equals of product 2, if it is true, and product 2 dot equals product 3 is also true, then product 1 dot equals of product 3 should also return true. It should also return true here. Yes. So you see, if these three objects are equal, then product 1 dot equals of product 2 should, if it returns true, product 2 dot equals, if it returns product 2 dot equals product 3 returns true, then definitely product 1 dot equals product 3 should also return true. Okay, or false. Not here. If product 1 dot equals 2 returns false, product 2 dot equals product 3 returns false, then product 1 dot equals product 3 should also return false. Yes. Either true or false. All the three statements should be same. Yes. The results have to be same here. Yes. Let me run this code. You see? You see? All the three statements written true here. Next, consistent. So for any non-null reference values x and y, multiple invocations of x dot equals y consistently returns true or consistently returns false, provided no information used in equals comparisons on objects is modified. Yes. So, multiple invocations of that equals method on the object references here. You see, if you got couple of object references, if you're trying to, sorry, if you're trying to compare them using equals method. So, see in both the cases, when you're trying to compare these two objects using this references, in both the case, in all the three cases, you see I'm trying to compare it thrice, three times. All the three cases, it should either return true or false consistently. The same result in all the three statements. Let me just run this code. Yeah. So hope this is clear for you people. So far, what we have discussed, is it clear for you people? Any questions in this regard? Okay, good. So now there is one last statement here. You see, basically this is also one of the equivalence relations. So for any non-null reference values x dot equals of null. If you compare that non-null object reference with null reference, if you compare non-null object reference with null reference, then it is supposed to return false. Okay, so it is supposed to return false. So let's see whether our method satisfies this rule as well or not. Product one dot equals of null. You see, it should print false, right? Okay, let me run this code. Oh, it won't. So the thing is, we didn't take care of this part. But you see, we got an exception. It says null pointer exception. What is an exception? So just for your information now, uh, it is nothing but an error which occurs during the execution of the program. Let's see why we are getting this error. Okay, so the thing is here, to the equals method we are passing this null reference. Null means nothing. Okay, so that null reference, where it is stored into this variable obj, in turn we are storing it into this product2 variable here. That null reference is assigned to this product2 reference variable. Now you know, on the null reference, if you call a method or using a null reference, if you call a method or if you access any variables, then actually that exception, that exception, null pointer exception will occur. Okay, Okay, so using the null reference, if you're trying to access any variable or if you're calling any method, so you'll get that null pointer exception. Now, we are not supposed that this method is not supposed to throw that exception here. Instead, it is supposed to return null. So for that, I'll add this. If product2 is not equal to null, then only we'll use that reference variable. If it is not null, then only we'll use that reference variable. Otherwise, this statement in line number 40 will execute and it returns false. Simply it returns false here. Yes. So is it clear for you people? Now let me run this code. See, it returns false. Yeah. So these are the rules which you need to follow while overriding the equals method here. You people can also check the documentation. Okay, go through it. Yes, that is what you need to do. So I hope this is clear, right? So please remember these rules and once, it's not that difficult to implement, you see. So by default, most of the rules, you will be satisfied if you're overriding the equals method this way, what I did here. Okay. Yes, fine. Let's move on. So what are the object class methods which we have discussed so far? Can you people list down the object class methods which we have discussed?
Equals,
Yeah,
hash code method,
yes. Equals hash
toString
code method
method,
to string.
toString.
So these are the methods which we saw now, right? So equals hash code and to string method. Now let's do one thing. We'll go through another method here, that is get class. Okay, get class method. The get class method here. Okay, before I talk about this method, I have to tell you people few things. I have to prepare you people for that. Yes, let me do that. Okay, you know, when the JVM, when it executes this code, the instructions which I've written here in the main method, when the JVM executes these instructions, you see it will come across this class, product class name. So we are asking the JVM to instantiate the product class. That means create an object for the product class. You know, whenever the JVM comes across this class name, so first of all, what it does is it will load that class into the memory. What it does, it will load the class into the memory. You know, the JVM, in order to load the class into the memory, it will take the help of class loader. So you've got something called as class loader, which will be responsible for loading the class into the memory. Yes. So class loader is responsible for loading the class into the memory. Okay. So why the class has to be loaded? When I say class is loaded, what does that means? I can say that the bytecode or the dot class file here, the dot class file will be loaded into the memory. Okay. For the product class, a dot class file will be there, right? The dot class file will be loaded into the memory, I can say. Yes. So once that class is loaded into the memory, immediately a class object is created. You know what? In Java, we got a class called as class. Yes. Okay. We got a class called as class. So this class object will be instantiated as soon as the class is loaded into the memory, and the details about the class will be stored into this class object. Yes. The details about the class will be stored in that class object, I can say. Yes. So once again I'll repeat it. The JVM, when it comes across the class, what it does is here, first of all, it will load that class into the memory. It will load the class into the memory. Yes, the class loader. And once the class is loaded into the memory, you know, immediately a class object. Which class? This class called as class object. We got a class called as class in Java, okay? And that class object is created, and the details about the class are stored in that class object. The details about the class are stored in that class object here, okay? Yes. You know why the class has to be loaded into the memory, and why the details of that class should be stored into a class object. So when I say details, what do people think what it includes? When I say details, what do people think what it includes? Yes.
Methods will be anything.
It includes the class name, the properties defined in that class, or variables defined in that class, yes, methods defined in that class. So all such details you'll find them in that class here, okay? All such details you'll find them in that class. Yes. So each and every detail. Yes. So you know that the class details you'll find that the JVM, it needs such details, because you see the JVM is responsible for creating that class object, right? And JVM is actually responsible for, sorry, JVM is responsible for instantiating that class, right? So we are asking the JVM to create product class object. JVM is responsible for that. And you see, JVM has to execute the methods defined in that class. So we call the methods, when we call the methods, JVM will execute the instructions defined in that methods. Yes. So that's the reason why JVM will make sure that that class is loaded and all the details about the class are stored in the memory so that it can use it for executing the code accordingly. Yes. Now, is there any option for us to read this, or is there any option for us to get that class object reference which is instantiated internally? Yes. As I told you people, a class object is created that, right? So is there any option for us to get that class object reference? I can say yes, it is possible. So that is where that get class method comes into the picture. So you can use that product object reference here. Okay. Yes. Call that get class method. It returns a class object. Okay. It returns a class object. Yes. So now how can we use this details? How can we use this details here? So I'll show you. First of all, we don't use this details much, but as of now, internally the JVM is using them. But let's see what details are stored in this class object here. Okay. Let's see what details are stored in that class object. Yes. So let's read that class name. We got that method get name. So get name method returns the class name now. Let's see. You see, you got the complete details about the class name, including the package details as well. It includes the package details as well here. Yes. Okay. Now, in this class, in this object, I'm sorry, in this class object, not only the class name is stored, even the other details are there. What are they? let's see. I'll read that method details. Okay. So class one dot get methods. You got a method called as get methods. You know what it does? This method returns. It returns a method array. You'll get a method array here. So method array. What is this method? Method is a class in Java again. You see the way you got a class called as class to store the class details. Similarly, we got a class called as method in which the method details will be stored. Okay, the method details are stored here. So the method class is from java.lang.reflect package. Okay, so you'll get a method array. Method array means basically what you'll have in this method array. If it is, if you have it, this type of array, the elements will be method object references, I can say. Method object references. Yes. So, you know, the get methods, what it does is when you call this method, okay, you'll find that it returns a method array, right? In this method array, you have method objects references, and each method object represents one method defined in that class. Each method object reference, which is stored in that method array, it represents one method defined in the class. So, for suppose in the class you got 5 methods, then how many method objects will be created? If you got 5 methods defined in the class, how many method objects will be created to store 5 method details? 5. That's right. So if you got 5 methods in the class, then 5 method objects will be created. And if you got 10 methods in the class, then 10 method objects will be created. Okay. Yes. And all that method object references, they are stored into a method array and they are returned here. So you'll get that methods array, which holds a method object references, where each method object holds one method details here. Yes, you see, this is Java. Java is object oriented. So in Java, everything is represented as objects here. Yes, in Java, each and everything is represented as an object. Yes, fine. So now I have a small task for you people. Can you people quickly write down a for each loop to read the elements from this array, method array? Write a for each loop to read the elements from this method array. Yes, I said for each loop. I want for each loop, not for loop. Okay, so I'll write down the code here. You can check this. You see the elements in this for in this method array are method object references, right? So in the for each loop, we'll declare a temporary variable of type method. Yes. Okay, you're passing that method object method array reference here. That's it. You're passing a method array reference. Yes. Okay. Now let's read this method names. Yes. Yes, that's right. Okay. Okay. So we'll read that method names. Get name. So first I'm printing the class name, and then we are obtaining that method array by using this get methods, which is defined in that class called as class itself. And once you got that method array, we're reading the elements from that method array and printing that method names here. That's it. Okay, so let me run this code. Yes. Okay, so did we define all these methods in the product class? Did we define all these methods in the product class? Yes. So few methods are defined in the class and few methods are defined in the sorry, few methods are inherited from the superclass. Okay, good. Okay, so there is one more method here called as clone. Let's see that clone method. Okay, so what is the meaning of clone? Generally clone means, right? What do we mean by clone?
A duplicate.
Yeah, clone means a duplicate or exact copy, right? Yes. So, the clone method which you got in the object class, yes, it can create a clone for an object, a copy of that object here. Yes, it can create a clone. A clone means exact copy of that object can be created. Exact copy of that object can be created. But by default, not all objects can be cloned. Okay? By default, we cannot clone all the objects. Not all objects are eligible for cloning. Not all objects are eligible for cloning. Then which objects are eligible for cloning? So is there any procedure to make the objects eligible for cloning? I can say yes. So by default, objects are not eligible for cloning. So we have to make them eligible for cloning. Yes. How do we do that? Yes. You know, for suppose you got this product class. I can say now the product class objects cannot be cloned. They are not eligible for cloning. If you want to make them eligible for cloning, then you need to make this product class implements an interface called as clonable. You have to make the product class implements clonable interface. It is also in java.lang package itself. So generally, when we talk about an interface, so what exactly you have in interface? Yes. Yes. So in an interface, we got abstract methods, right? Normally in an interface you'll have abstract methods, but in this interface there are no methods. So this is just a blank interface. You know, this is just a blank interface. There are no methods in this interface. Okay, no methods defined in this interface. This type of interface is called as a tag or marker, sorry, tag or marker interface. Okay, tag interface or marker interface, both means the same. You know, in a tag interface, there are no methods defined. It's just a blank interface. Then why we have to make the class implements this interface here? Yes, if it is blank, then why we need to make this class implements that interface? Yes, you know, by making this class implements the interface, just making this product class objects eligible for cloning. We're making the product class objects eligible for cloning. It's just a tag, I can say, a tag. Yes, we are just tagging this class that this class objects are eligible for cloning. Okay, yes. You got the point, all of you. We're just making this class eligible for cloning. We're making this class implements this interface. We're making the objects of this class eligible for cloning here. That's it. Yeah. Now once the class is the objects of the class are eligible for cloning, now we can clone them. Okay. But I would like to take some time to discuss about it. So because it is little tricky, so we'll do it in the next session. Okay. So I'll stop it here today. So the next thing is cloning itself, and then we'll be done with object class methods. Other methods we'll discuss about it at appropriate times. So these are the only methods which we can discuss now. In the next class, I'm going to talk about memory management as well. Okay, I'll introduce you people to memory management. Yes. So we'll see how to override that equals method, sorry, clone method. It is slightly different. It is not that simple and straightforward, or overriding that equals method. Okay. that we'll see in the next session. Okay, fine. So let's meet tomorrow and continue discussion. Yes. Uh, Hope whatever we have discussed today so far is clear for you people, right? Please make sure that all these methods which I discussed, you implement them in the, or override them appropriately in your classes, okay? Most of the methods are most common methods. Hope you might have noticed it already. Yes. So they represent the most common operations, as I told you people. Yes. Fine. Okay then. So have a good day, all of you. Great day. And good night as well. Yeah. Thank you. Bye bye.